All right, guys, welcome back. And here we go. We're just going to put it all together now. So we're going to actually solve for missing sides or angles in right triangles. So here's a type of problem I'll ask you to do. So we're given a right triangle. First thing I'm going to do is at the top of my paper, I'm going to write ka toa, so I can determine which trig ratio to use. So the very first step is determine what sides you are using relative to the given angle. Here's what I mean. Here's the angle. Boom. And here are the sides that I'm dealing with. This one and this one. So notice how I got nothing over here. I'm not trying to find it. I don't have it, so I don't care about it. So what is x relative to this angle? Well, it is the hypotenuse. What is 12, this side, relative to this angle? Well, it is the adjacent leg. That is step one. What side you got? We got the adjacent, we got the hypotenuse. Step two, which trig ratio should we use? So I look at my SOHCAHTOA acronym, all right? And in SOHCAHTOA, which one uses A and H? Cosine does. So I will simply say, all right, this is a cosine problem. Step three, set up the equation. So then you say the cosine of the angle, so cosine of 32 degrees, is equal to adjacent over hypotenuse. Adjacent is 12 over hypotenuse is x. And now we simply need to solve for x just like we did in these previous examples here. And notice x is in the denominator in the problem we're currently working on, so I'm simply going to do the little swap trick that I taught you. So when the variable is in the denominator, I can simply swap these two things. So I can say that x will equal 12 divided by the cosine of 32. Now, you can use the table, of course, and you can get a decimal for cosine of 32, or you can just go straight to your calculator and type it in. That's what I typically do just to save a step. And I'm just going to do 12 divided by the cosine of 32. And I get that x is 14.1. I didn't tell you how to round this one, but pay attention to the directions, of course. But x is 14.1. There we go. And whatever units you'd be dealing with. It's linear units in this case. Sweet. So it's that easy. It all sounds so complicated in the beginning, right? Trigonometry, SOHCAHTOA, all this stuff, sine, cosine, tangent. But really, guys, once you get the hang of it, it's pretty straightforward. Let's just do a couple more examples, right? Well, actually, hold on. Let me check this. Oh, man, I should have rounded to 0.2. 14.15, oops, is 14.2. I didn't see that 5 there. All right. Just a couple more examples. So I'm just going to follow that same protocol. The first step is here's my angle. Here's that 65 degrees. And relative to that angle, the 12 is the hypotenuse. And the x is the leg that's opposite the 65. Notice how this adjacent leg is not involved whatsoever. I'm not trying to find it, I'm not given it, so I don't care about it. So then I think about my acronym. Which one of those, sine, cosine, or tangent, uses O and H? Well, sine does. So this is a sine problem. And the sine of 65 degrees is equal to opposite, which is x, over hypotenuse, which is 12. And now in this case, I'll simply multiply both sides by 12. And I'll get that x is equal to 12 times the sine of 65. And how about in this case, I'll do it using the table, just to show you, if you don't have a graphing calculator, it's not that big of a deal. So the sine of 65 degrees is 0.9063. So x is equal to 12 times 0.9063. Double check that. 65 degrees, 0.9063 is sine. Sine is the first one. Sweet. And now you do need your calculator, some sort of calculator. You can use your phone or whatever you need to use to multiply 12 times 0.9063. And you get that x is about 10.9. Sweet. All right, next one. So the next one, here's my angle, 40 degrees. Relative to that 40, I do not have the hypotenuse. The 5 is opposite. What I'm trying to find is the adjacent leg. Which one uses O and A? TOA. So this is a tangent problem. The T is tangent. The tangent of 40 is equal to opposite over adjacent, which is 5 over x. And because the variable is on bottom, I'm going to do the old swaparoo. You get x is equal to 5 divided by the tangent of 40. And this time I'm just going to type it in my calculator and avoid using the table, just because I think it's a bit faster. 5 divided by tangent of 40 is about 5.95, which will round up to 6.0 if I'm rounding to the nearest tenths. There you go. And that's solving for missing side lengths in right triangles. All right, and last but not least, how do you solve for missing angle measures? This actually works to be a little bit faster, and the process is similar. So here's the angle that I want to solve for, and relative to that angle, 13 is the hypotenuse, and 12 is the adjacent leg, the leg that's touching it. So if I think about my SOHCAHTOA, I can see which one uses A and H is cosine. So I'd say the cosine of theta, that's the angle I want, is equal to adjacent over hypotenuse, which is 12 over 13. Now, so I determined what sides I had. I determined which trig ratio to use. I set up my equation. And now the last step for this is to work backwards. Okay, so I'm going to show you how you can work backwards either using the table or the calculator. All right, guys, sorry, I kind of glitched out there. Anyway, where were we? We were at cosine of theta is equal to 12/13. All right, so I was going to show you how you can work backwards to find the angle measure using the table first. So you still have to use the calculator to determine that decimal, and 12 divided by 13 is 0.9231. So I've got the cosine of theta is equal to 0.9231. Confirm that. 9231. Good. All right, now I'm going to go to my table, and I'm going to find the cosine value. Zooming in a little bit. I'm going to find the cosine value that's closest to 0.9231. So cosine 9231. Closest one looks to be right around 23 degrees here. That's the closest to 0.9231. So theta is approximately, let me just double check that. Yep, about 23 degrees. Nice. All right, now let's show you how to do that by using the calculator. So in using the calculator, we have these little inverse operations. This means inverse sine, inverse cosine, or inverse tangent. So that little -1 thing, you don't read it as sine to the -1, you read it as inverse sine. Okay, it undoes the sine or cosine. So I know that the cosine of some angle is 12/13, so I want to undo cosining. So what I'm going to do to both sides is I'm going to do the inverse cosine of both sides. And when I do that, inverse cosine and cosine are inverse operations that cancel out. So I get theta is equal to the inverse cosine of 12/13. So all I got to do now is just in my calculator, type in inverse cosine of 12/13, and I get around 23 degrees. So theta is approximately 23 degrees. It does not matter. You can use the table and work backwards, or you can use your calculator. There's 2 more examples. Maybe I'll do one of each. I prefer the calculator because it just is a little faster. All right. So here we go. In this case, here's my angle. And relative to that angle, let's see, the 5, of course, across from the right angle is my hypotenuse. And the 4 is the leg that's opposite. It's not adjacent, it's opposite. So then I'm going to think, all right, SOHCAHTOA. Which ratio uses O and H? Sine does. So I'm going to say the sine of theta is equal to 4 over 5. Now, I'll do this one by using the table. All right. So sine of theta is equal, now 4/5 is 8/10. So that's 0.8. You can, of course, punch it in your calculator if you want the decimal. but sine of theta is around 0.8. So I'll use my table. Remember, sine is the first column, and I'm looking for the one that's closest to 0.8. I'm not there yet. Sine closest to 0.8 looks to me like it's around, this is 0.809, somewhere between 53 and 54. I'm going to go with around 53 degrees, it looks like. So sine of theta is around 53. Sorry about that. We had a package delivery and my dog went bananas. Alright, so there you go. Theta is about 53 degrees. Now, over here, in this one, here's my angle that I'm dealing with. This is opposite leg. I don't know the hypotenuse, I'm not dealing with that, and I know the adjacent leg. Which one uses O and A? Is tangent. So I'd say the tangent of theta is equal to opposite over adjacent. Now this time I'm going to use my calculator, so I'm going to inverse tangent both sides. So theta will equal inverse tangent of 33 divided by 54. Take the calculator, inverse tangent, 33 divided by 54, and I get that theta is approximately 31 degrees. Alright, there you go. So now you know how to solve for, well hopefully you know how, but now you can try to practice and let me know if you need help. But you can use trigonometry to solve for missing sides like we did in these first three examples, and missing angles like we did here. And the key thing is whenever you're using your calculator to solve for an angle, that's when you want to use the inverse option in your calculator. So on the Schoology page, there's a scientific calculator link on the main page, and this table is also in the Chapter 12 folder. So you can find this table in that Chapter 12 folder as well. So good luck on your assessment, and let me know if you have any questions.